be important. All right, the recorder is on, and it is recording the correct audio channel. So I'm going to get started. All right, so this is the last lecture of cisp300. We have our final exam next Monday at the usual, exam time. So do you guys remember what time the exam starts?
12:45. 12:45.
12:45. Let's double check. Okay, so we want to double check, make sure that we get here at the right time. I think I checked it, once, already, but it doesn't hurt to double check and make sure. So we go to ARC, and then we want to look up the exam schedule, spring 2016 final exam schedule. And this class starts exactly at noon, so the start time is noon. It's a Monday, Wednesday class. So we are going to have our final exam from 12:45 to 2:45 p.m. on Monday, Pacific time. Well, just in case someone says, well, I thought it was GMT. No, it is Pacific Daylight Saving Time, so it's PDT, not even Standard Time, because, yeah. So is that okay? Does everybody know when to show up? Okay, all right. So last time on Monday, we were working on the practice final, which is based on the final questions of one of the semesters. So we are going to continue with that today, just so that we can see, all of the questions from before. So let's see. I think we went through only 2 of these. Did I go over MX5 or just MR2? I think MR2 was the last one. So let's take a look at MX5 and see whether we have gone through this one or not. Because I'm pretty sure we haven't gone through all of them. And this one, no, we haven't gone through this one. This is new, okay? So we're gonna go through this one and see if we can figure this out. This one has got, by the way, this one has no structures or no records in it. In other words, this only, it has all the stuff that you need to know for exam 2. So the material after exam 2 is not even in this question. It does have recursion, has all the usual concepts, but nothing related to records. All right, so let's take a look at this program, and we'll figure out what it does and how to trace it. Sheet 2 is the trace, and it doesn't have anything to start with because there's no need, because this one does not require anything to be initialized before you run the code. And there's a particular number that we pass to n to start the entire thing. All right, so do we have any questions about the code itself? Just reading the code, are there any questions? No questions? Okay, so let's go ahead and start the trace. So we open a new window, switch to the second sheet, and make it smaller. So this way we can display the algorithm on one side and display the trace on the other side. And I probably want to zoom in just a little bit more, but not too much, because we don't have that much screen space to begin with. There we go. And I can shrink this one a little bit, just so that we have more room for the other one. There we go. All right. So in this case, we do need the comments column because there are conditions to evaluate. There are conditional statements. And then we have line number. And then we have to say, okay, do we have any global variables? So what you need to do is to go through all the names, and say, okay, is that a local variable? Is that a parameter? If it is neither, then it's probably a global variable. N is a parameter passed by value. K is a parameter passed by value. And those are the names that we refer to throughout the entire program. So we don't have any global variables. So as for the precondition, there's nothing to specify. Okay, so we start execution on line 18, which is the first line outside of the definition of a subroutine. And the first thing we do is to invoke MX5. And MX5 does return a value. We can see that it has return here. they all return a particular value, which means we have to use return info because we are getting back to line 18 after the invocation to finish off what we have to do on line 18, which is printing the value that is returned. But on top of that, we also have to pass the parameters. We have two parameters to pass. One is n. Parameter n starts with the value of 191. That's because the invocation itself said so. And then we have parameter k, which has a value of 1. So here's k, and it has a value of 1. So after all of these columns are set up, then we can continue execution in the subroutine, starting on the first line, which is line 4. Line 4 is asking, is n less than 10? Well, n is 191, which is not less than 10, so the answer is false. That means we have to go to the else part here. So the next question on line 11 is asking, what is the result of n mod 10? Does it equal to k? N is 191, mod 10 is the remainder of division by 10. So it does have a remainder of 1 because k is also 1. So this part is true. Okay, I just want to show you guys the parameters. See, this is a 1, and 191 mod 10 does have a value of 1. So we move on onto line 12, which is the then statement. So here's line 12. Line 12 looks kind of complicated because it is returning the value of an invocation plus 1. Well, so what we need to do is to prepare for the invocation. So we need to allocate the 3 columns. The return info column, a parameter n column, and a parameter k column. K is the easy one because whatever k I get is the k that I use to specify for the next invocation. Since k was 1 from my perspective, it is going to be 1 from the perspective of the next invocation. Then we get back to n here. Now n is a little bit more complicated because we have to take the floor of n divided by 10. The current n is 191. 191 divided by 10 is 19.1. But since it's an integer division, it is 19 anyway. But 19, even if you look at it as 19.1, the floor of 19.1 is the largest integer that is less than or equal to 19.1, which turns out to be just 19. So for the next invocation, n has a value of 19. And then the return info cell has to indicate when we are done with an invocation on line 12, what do we have to do? Where do we go, and what else do we have to do? So the answer to that is we have to get back onto line 12 because the return is not done, and there's also a 1 that we have to add to the return value before we can return. So that's why the return info cell looks like this. And once again, the return info cell is really the same as the line that we are dealing with the invocation itself replaced by a single question mark. That part has not changed ever since we introduced the concept of returning a value. Okay? Are there any questions at this point about how the columns are set up? Okay. So now we move on because now the invocation is happening. So we continue execution on the first line of the subroutine that we're invoking. Since we're invoking MX5, the first line is line 4. Oops, wrong place to do that. Yeah, let's undo this. Go back to the other one. Okay, so here is where we have to specify a 4. And then we do this comparison again. N is less than 10 is false because n is 19 at this point. N is 19, n mod 10 is 9. 9 equals to 1 is false. And this is happening on line 11. So we have to go to the else branch of the inner conditional statement. In this case, it is on line 14. So on line 14, we have to do the recursion, but this time without the +1. So we go to this line 14 here, and then we set up the same 3 columns. We have return info, we have parameter n, and then parameter k. Once again, parameter k is easy because we are just passing that 1 along. Parameter n is still the floor of n divided by 10. This time n has a value of 19. 19 divided by 10 is 1.9. The floor of 1.9 is just 1. So we put, oops, keep using the wrong window here. So we put a 1 here, and then return info cell has to indicate when the invocation of MX5 on line 14 is done, where do we go, and what else do we have to do when we get back there? So we have to get back onto line 14. Yep. Question? Oh, okay, sorry. Okay, so on line 14, we have to get back onto line 14 because we got the return to be done, but this time it doesn't have a +1 because the +1 is only happening on line 12, but not on line 14. So when all of these columns are set up, we continue execution in the subroutine that we are invoking, which is line 4. So there's a little bit of scrolling here, so we continue execution on line 4, and I cannot track it either. It's not just you. So we have to use row 13 for this purpose. We got back here, and then we just say, okay, continue execution here on line 4, and that will ask the same question again. N is less than 10 this time is true because n has a value of 1. And as a result, we go to line 5 to ask the second question, which is n is different from k. N is 1, k is 1 as well. 1 is different from 1 is false. So that means we have to go to the else branch, which is on line 8. So we go to line 8 here. And line 8 has a simple thing to do. It is just saying, oh, let's go ahead and return the value of 1. So we go to the rightmost return info cell, copy and paste it, and say replace the question mark with the value of 1. And that's all we have to do on row 18 of the trace. Then we move on. Now when we move on, there's nothing else that we have to do in the inner conditional statement. So the conditional statement starting on line 5, we have come to an end for that conditional statement. But that conditional statement turns out to be the only statement of the then branch of the conditional statement starting on line 4. So we are done with that one as well. So we're getting out of both conditional statements, and we end up on line 17, which is the end of the entire subroutine. So at the end of the entire subroutine on line 17, we got 2 things to do. The first thing we need to do is to make a note of where are we going back to. So we're going back to line 14. So we make a note of that. Okay, so put it here. And then on line 17, we are going to deallocate the columns that we have allocated for this invocation. So that will be these 3 columns. And I have to track on which row I have to indicate is row 16. So on row 16, I have to indicate that all of these are done. So we do a right click on the font, select strike through, and so we are now done with line 17. When we are done with line 17, we are proceeding to line 14 because that's how the way we know that we are proceeding to line 14 is because of the return info cell. So that's why the return info cell is useful, because it tells us where do we continue execution after the end of an invocation of a subroutine. So on line 14, this is what we're supposed to do, which is just executing the return 1 statement. So when we return 1, once again, all we have to do is to go find the rightmost return info cell that is still currently in use, which is column F this time. So what we want to do is to copy and paste it. Once again, I forget which line number or which row we're dealing with. It's row 17. So we copy and paste it and replace the question mark with the value that we are returning. In this case, it is 1. But we don't change the 1 plus 1 to 2 at this point because the job of a return statement, which is specified in the line number column, the only purpose of that return statement is to change the question mark. But we do not do anything about the return info cell. This is not the right time to do it. So after line 14, which is here, we get out of the inner conditional statement of the else of the outer conditional statement. But since the inner conditional statement is the only statement of this else, we are also getting out of the outer conditional statement. We're now getting back to line 17. When we get back onto line 17, we do the usual stuff, which is making a note of where we are supposed to go. So if you look up here, we are supposed to go to line 12 according to the return info cell. So we make a note of that, and then we have no use of these 3 columns anymore. So we indicate that these 3 columns are now deallocated, and continue execution on line 12. Line 12 now says, just return 1 plus 1. 1 plus 1 is 2, so we are returning a value of 2. When you execute return 2, it means look up the rightmost return info cell, copy and paste it, change the question mark to the value that we are returning. So in this case, we are looking up the rightmost return info cell, which is column C here. We copy and paste it, change the question mark to the value that we are returning. 1 plus 1 is 2, so we are basically just returning, whoops, I overwrote the wrong part. So we are just returning a 2, we are changing the question mark to a 2. So we're done with line 12 at that point. When we're done with line 12, we get out of the inner conditional statement, which is the only statement of the else branch of the outer conditional statement. So we're getting out of the outer conditional statement as well. So now we end up on line 17. And then on line 17, once again, we just have to make a note of what to do next, which is on line 18. We have to print 2. Then we have no use of these 3 columns anymore. And we just go ahead and copy and paste it, change it to strikeout, so that we know that these 3 columns are now deallocated. Now we continue execution on line 18, which is just printing a value of 2. And as I described in the previous class on Monday, when you execute the print statement, just go ahead and use the comments area to say that we're printing a value of 2. That's all we need to do. And after line 18 is the end of the entire program. So we put a post here, and now we are all done. Are we doing okay so far with this? Okay. So just for the purpose so that you can copy and paste the content a little bit easier without having to scroll through a whole bunch of stuff, I'm just going to display the entire spreadsheet without all the scrolling. So this way, when you watch the YouTube video, you can just freeze the frame, and now you have an idea of how the entire thing looks like. Yep. Does the pre and post condition question involve recursion? No, it won't involve subroutines at all. Unless you guys want to.
No. Extra credit question.
Extra credit question. We'll have recursive subroutines and prove the correctness of the subroutine itself. That's the job of cisp 440. Some of you will see me again in cisp 440. And 310, because only I teach those 2 classes. I don't see any major disappointments, I guess. I will take it as a good thing. All right, so are there any questions about this particular trace? This one is actually, quote unquote, fairly straightforward because it only involves the concept prior to exam 2. Are we good? Okay, so let's move on to the last question of this bunch, and let's see, where is it? It's here. Okay, so the last one is RX7. So let's take a look at RX7. And once again, this one does not involve records, which is good in the perspective of, it's fairly easy to trace, but it's bad from the perspective of it doesn't give you another practice for records. So I will probably give you guys another question that has records in it, because I think you guys probably can use another one that shows how we can combine the different concepts. Okay, so with this one, we just take a quick look at this and go like, okay, do we have anything that we haven't seen before? And the answer is no. Everything here should be stuff that we have seen before. Local variable, okay, instead of a parameter, R is a local variable. And then we have the return statements, no big deal. So let's go ahead and trace this one. It shouldn't take too long. So open up a new window to look at sheet number 2, and resize the window so that we can see that portion separately. There we go. And zoom in just 1 notch, or a few. just so that we can see more of the trace, comments, line number, the usual stuff, the precondition. And once again, we do not have any global variables because n is a pass-by value parameter, r is a local variable, and there are no other names involved. And as a result, there are no global variables in this entire program, which means the precondition really has nothing to say. There's nothing to say about what is true prior to the execution of this program. So we move on to line 15. And once again, line 15 is a print statement. It's printing the return value of invoking RX7. So we have return info here. We're going back to line 15 to finish the printing. And then we have to specify the parameter, which is n. N starts with a value of 6 because that's what the invoke statement is, or the invoke expression is specifying. We have a local variable r. And as a local variable, it is always unknown to begin with. And that's why we have a question mark. So now we are ready to move into the subroutine, starting on the first line of the subroutine itself, which is on line 4. On line 4, we are asking, is it not the case that n is less than 2? N has a value of 6. 6 is less than 2 is false. Not false is true. So this entire expression is true. Then we move on to line 5, because when the condition is true, we move on to the then branch. Line 5 is an assignment statement, but we cannot do the assignment. We don't know how to change R until we get the entire right-hand side resolved, which involves a recursive call to RX7. So that means we have to specify a return info cell and an R here, because we are doing the recursive call. The return info cell will specify that we go back to line 5 so that we can finish up the entire assignment operation. N is going to be the floor of the current n divided by 2. N is 6 at this point. 6 divided by 2 is 3. The floor of 3 is 3. And then R is a local variable, so it starts with an unknown value. So this is how we set up the columns for the next invocation. This is the second invocation of RX7. Then we continue execution on line 4 again, and then we ask the same question. N is less than 2 itself is false, not false is true. We go to line 5, so now we have another level of recursion. So I'm just going to be lazy here because it is for the most part the same thing with only one difference. The only one difference is N, because this time n is 3 divided by 2, and then we take the floor of that. The floor of 1.5 is just 1, so it is just 1 in this case. And then we combine the 3, or we shrink the 3 columns. Somebody asked me, how to resize all the columns at the same time. The key to do this is to select the column using the column header, and not to select your columns or the individual cells of the column. So if you select the columns like this, then you can find any place in between the columns. Whenever your cursor becomes a double-sided arrow, double-click it, and it will resize all the columns currently selected. Okay, so now we get back to line 4 again. On line 4, we ask, is it not the case that n is less than 2? N is 1 in this case. 1 is less than 2 is true. Not true is false. So the entire expression is false. We have to go to the else branch, which is on line 7. Line 7 doesn't do anything really that interesting. All it does is to change R to 0. But we have to remember which R to update. It is the rightmost one. So it will be column K that is now updated to a value of 0. Then we are done with the inner conditional statement, or the first conditional statement. Then we move on to line 9. Now remember, line 9 is not an inner conditional statement. It's sequential to the first conditional statement. So now we have to ask the second question. N mod 2 does not equal to 0 is, n is 1. 1 divided by 2 has a remainder of 1. And 1 is different from 0 is true. Okay. So this is true here. And if that one is true, okay, let me just expand the comments column. So if that one is true, then we have to go to the then branch, which is on line 10. Line 10 is returning R. R has a value of 0, so we're returning a value of 0. That means we are going to copy and paste the return info cell, change the question mark to the value that we are returning, which in this case is 0. then we are done with line 10. After line 10, we are going to go straight to line 14, which is the end of the subroutine. It has got two things to do. One is to make a note of where to continue execution. The second one is to deallocate the columns specific to this particular invocation. Now, I'm not sure how many people actually remember or make a note or notice that when I say this is the end of this invocation, rather than this is the end of this subroutine. Okay, because a subroutine can have multiple invocations simultaneously. So when I say it's the end, I have to be specific about the invocation and not the subroutine itself. Okay. So now that we have done all the deallocation, we continue execution on line 5. Line 5 is now just, we want to change R to 0. The R that we are talking about, once again, is the rightmost column that has a label of R. It is not column K anymore, it is now column H. So column H is the one that has changed from question mark to 0. After line 5, we are getting out of the first conditional statement, moving on to the second conditional statement starting on line 9. N has a value of 3. 3 mod 2 is 1. 1 is different from 0 is true. So this time we have, wrong place. We have N mod 2, which is 1, different from 0 is true. So once again, we get to line 10, which is returning R, which is 0. So when we execute return 0, what we do is we look up the rightmost return info cell, copy and paste it, change the question mark to the value that we are returning. In this case, it is a 0. And then we move on to the end of the subroutine, which is on line 14. Same thing, we make a note of where to continue execution, which is line 5. And then we deallocate the 3 columns specific to this invocation. So we just strike out. Now we continue execution on line 5. Once again, we are changing R to 0, but this time R is referring to column E, which is the rightmost column with a label of R. So change this one to 0. That's the effect of executing line 5. And after that, we continue on to line 9, which is the beginning of the second conditional statement. And then we ask the question again. N is 6 this time. 6 mod 2 is 0. So being different from 0 is false. So we go to the else branch. The else branch is on line 12. Line 12 says return R plus 1. R has a value of 0. 0 plus 1 is 1. So we're returning a value of 1. We look up the rightmost return info cell, copy and paste it, change the question mark to the value that we're returning, which is 1. And we're done with executing the return statement on line 12. Now we move on to line 14. We have 2 things to do. One is to make a note of where to go to continue execution. The second one is to deallocate the column for this particular invocation. And now we continue execution on line 15. This is the second time we get to line 15 because we started off with line 15 to begin with. But the second time we get to line 15, we know exactly what to do because now we know the value that we're supposed to print is just 1. So we say print 1 in the comments column. Then we go to post, we're done. Are there any questions about this particular program? No questions? Yep.
Is this just determining if n is an odd or even number?
Yeah, that's the function of line 9. Because when you divide a number by 2, you can only get either a remainder of 0, meaning the number is even, or you can get a remainder of 1, which means the number is odd. Any other questions?
Can you move another screen?
Okay, so we'll take a look at the screen, maximize, and so that you can zoom out a little bit. So this way, when you look at this from YouTube, you get the entire screen, take a screenshot, print it out, do whatever you want with it. You can actually just take a screenshot, print it out, and take it with you to the exam. But it's not going to be helpful unless you know why we do these things to the columns. So that's one thing that a sheet of paper cannot do, is to explain to you what happens step by step. So what that also means is once you print this out, you might want to annotate it using your own text and describe, okay, from here to here, this is the reason why we are allocating these columns. From here to here, this is why we updated the question mark, and so on, if you feel that will be helpful. Is that okay? Okay, so just remember, you can only bring material that is either printed or handwritten or both prior to the exam, during the final exam. So I don't want anyone to ask me, can I watch your YouTube again during the exam? The answer is no, you cannot.
What if I print each frame and I flip?
You can flip through the pages fast enough that it is an animation, yes. Because it's paper-based animation. I just said no electronics, I didn't say no animation. So you can do animation by flipping pages really fast.
Take a lot of photos.
You can even
As long as the
crinkle.
subtitles were good.
You can even crinkle the paper to the point where you can kind of like scratch through the whole thing, and it's actually my voice being played. I'm sure someone has a special 3D printer that can do that. That would be awesome. With a 3D printer, you feed an audio file to a 3D printer, and by scratching the surface of whatever you're printing, it will reproduce the sound.
Just one question. Don't you have to convert the audio to 3D before you can print it?
Yep, you do.
It's not that hard.
And with 2 needles on 2 fingers, you can now have stereo too. And with 5 fingers, you can have surround sound.
Or you could just study.
Sorry?
Or you could just study.
Or you can study and understand the concepts, yes. Yeah. But I am obsessive with technology.
That's good.
Yeah. Okay. So the next thing I want to do is to go back to records, because I think it is kind of important to see how we can combine the concepts. Okay. So we'll go back to records, and I'm just going to put it into sheet 3 in this case, and write this really kind of rather simple program. So we'll say define sub XYZ by reference. Okay, so we pass by reference one parameter called x, we pass by reference another parameter called y, and the only thing I'm going to do here is to say x gets x plus 2, y gets y minus 2. Okay, I'm increasing one by 2, decreasing the other one by 2, and that's the entire subroutine here. Doesn't do a whole lot. So by itself, this is not something that we haven't seen. Okay, we have seen stuff like that before. And here's the other subroutine, which is the main subroutine. And we say by, it's a local variable, and I need some extra space. I don't need it here. Okay, I'll do it over here. So I have to define the record here. So I say define record ABC. And in ABC, I have a member called I, which is an integer, and I have a member called J, which is, well, let's not use J because it looks exactly like I, so K. It's also an integer and record. So now I have a record definition, and remember, a record definition is just a cookie cutter. It is not a variable. There's no way you can store anything into ABC itself, because you can only use it to create variables where things can be stored. Okay, so now that we have a record type, we can define sub main, and inside main I have a local variable. I would just call that v, which is of type ABC. And just to be consistent, I should probably also mention that x is an integer and y is also an integer. So this time, we are specifying the type of everything. Okay, so in the main program, I'm just going to do some initialization here. I say v dot I gets a value of 16, and then v dot k gets a value of, 27. And then we invoke the subroutine XYZ. Now here is where the combination of the concepts apply, because I'm going to pass member I of v as parameter x, and then member k of v as parameter y. Okay, so we have this to specify parameter x, and then we have that to specify parameter y. Okay, so here's a combination of concepts, 2 concepts. and we want to figure out, okay, I haven't seen anything like this, we haven't seen this combination, what is going to happen here, okay? So that's the purpose of this particular program. And define sub, invoke
Same
main.
thing with array slots the same way, right?
Sorry, say this again?
Same thing with array slots the same way.
Pretty much, but this is kind of the reverse of that, because we start off with something that's bigger, but now we are specifying only a portion of that. But but I think what you meant is the same thing as using a particular element to pass. Yeah,
Correct.
yeah, it is exactly the same as that. Okay, so we want to do the indent like that. Okay. And before we actually trace this, let me just start with saying, it is impossible for me to enumerate all possible ways to combine all the different concepts. That's just not possible. Even if it were possible, it would defeat the purpose of this class to give you an explanation of every single way to combine all of those features, because I want you guys to be able to figure it out. Okay? Because when you're programming in the real world, you have to learn the programming language on your own. And programming languages are described by saying, okay, this is array indexing. This is how you get to one particular thing in an array. This is how you get to one particular member of a structure or record. And this is how you pass by reference. But it doesn't tell you how to combine these things. So you have to understand each one, and then you just say, okay, this concept involves this type of mechanism. That concept involves the other mechanism. Now we are just combining the two mechanisms, okay? All right, so now we'll go ahead and trace this using the next sheet. So we start off with this, unmaximize. Okay, so we got this. That's good. All right. So in this particular program, we do not have any conditional statements, so I don't have to make a comments column. Line number starting with line 7, starting with a precondition. There are no global variables in this case, so there are no global. So what we'll do next is to start execution on line 17, and we are invoking main. Main has a local variable called v, so we have to allocate the columns for v, not a single one, because v is of the type ABC. ABC is a record that has two members. So that's why v has is going to occupy two columns. The first column, excuse me?
You forgot your red line.
Huh, what?
You forgot red line.
Oh, okay, the return line number, okay, thank you. So the return line number is post, I forgot because it's not the most exciting part of it.
Yeah. Jumping ahead of yourself.
Yeah, time warp, you have to go
Yeah.
back.
It's fine.
Yep, that's why we need we need TARDIS. All right, so now we specify the local variable called v, but v has two members, so that means it is going in this case, each member only takes up one column because each member is just an integer. On the other hand, if a member is also a record type, then it can potentially take up multiple columns. Okay, so member I has its own column, member K has its own column, and because it is a local variable, each one has its own question mark, because we can initialize one without the other one, and that's why you cannot use a single question mark for both columns. And technically speaking, V is referring to both cells and not just one, so technically speaking, I should use V to, it should span across both column C and column D. All right, so there we go. All right, so continue execution into main, starting on line 13. Line 13 says I want to change member I, excuse me, member I of V to 16. All right, we change that to 16, and then we change member K to 27. And here's the part where we are combining the concepts, because we are on line 15, we're calling the subroutine called XYZ. Return line number is the following line, which is line 16. Now we have to specify the two parameters. The first parameter is X, the second parameter is Y, and they are both passed by reference. So now the question is, what am I going to say about X? Is an alias of which column? So Well, we look at this part here, we look at line 15, and we say, what do we use to specify parameter x? We are using member I of V to specify x. X being a passed by reference integer should be the alias of a particular column. So which column do you think x should be? Should be an alias of?
C.
Column C, very good. Okay, so AKA column C, and then Y is AKA column D, just like that. Is that okay?
Yeah.
Alright, very good. So now we go into the subroutine starting on line 4. Line 4 says x should get x plus 2. X does not have a value, okay? It is an alias of another column that has a value. So x basically says, don't look at me, look at column C. Okay, fine, we'll look at column C. Column C has a value of 16. So the right-hand side of line 4 is 18. And we're going to store 18 back into x. Once again, x says, don't store anything in this column. Go look at column C. Column C is the one that's going to get the new value of 18. On line 5, it is kind of the same thing, but we apply it to y and we're subtracting instead of adding. Because y says, look at column D starts with a value of 27. So when this is all done, it ends up with a value of 25. And when this is all done, after line 5, we get to line 6. Line 6 is going to make a note of where to go to continue execution, which is on line 16. And then it will deallocate the 3 columns for this particular invocation of XYZ. Like that. So now we continue execution on line 16, which doesn't really do anything interesting, because we make a note that we have to go to post and then deallocate the 3 columns, not 2. Okay? There are only 2 things, but out of those 2 things, we are making use of 3 columns. So we say that and strike through. Like so. Now we continue execution at post, which means we're at the end of this trace. It's all done. Yep, go ahead.
What's the difference between a structure and a class or a record?
They are basically all the same in this class, but in the case of object-oriented programming, so without object-oriented programming, a record, a structure are basically the same thing. The term record comes from Pascal, and the term structure comes from C and C++, but they basically mean exactly the same thing. Now, when you refer to that thing as a class, then it becomes an object-oriented programming term. And we do not deal with object-oriented programming in this class, but when you use the term class, it implies that you can do inheritance. It implies that you can have methods associated as a member of a class definition and all the other good stuff in object-oriented programming. But since we are not doing object-oriented programming in this class, so we just say that we just basically look at the class as a souped-up version of a record. But it is derived from a record or structure, from the evolution point of view of programming languages. Yep.
Just a quick question. I was trying to stay a step ahead of you to see if I was doing it right. And one thing I messed up on was on line 16 when I was deallocating that column, I wrote the turn line and then variables I and K instead of B. Would that have been incorrect?
No, it would still be okay. I mean, you can say you're deallocating v.i and v.k individually, or you can just say you're crossing out the entire thing, but you have to make it clear that it is both columns.
Yeah, I crossed out both columns.
Yeah, that's good. That's the important part is we have B, C, and D, deallocated. Yep.
Cool.
All right. Any other questions?
Those little arrows where it's like the 2 pointing little arrows, that means it's going to be referring to another column?
The double-sided arrow on line 15 is just my way of denoting or emphasizing that these are passed by reference, so that whatever happens to the parameter happens to the original thing. That's why it's a double-sided arrow, as opposed to passing by value, it's only a right arrow, because whatever happens with the parameter doesn't get reflected back to whatever you use to specify the parameter. So that's my intention to kind of make it extra clear that this is passed by reference, that is passed by value, and so on. Okay. Are there any questions about this particular program? Okay, there are no questions about this, then we'll take a look at something that will combine arrays with records. Now there are two ways to do that, because you can have a record with a member that is an array. You can also have an array where each element is a record.
Oh, that's busy.
Huh?
That's gonna be
Well, it depends on how busy we want it to be. We don't have to make it really extra busy. Okay, so let's go take a look at that particular example. So once again, we make up a new sheet for the algorithm. So we're going to start with defining a record. Once again, I just call this ABC. It has no particular purpose other than as a demonstration in this class. It has two members. One is called X and one is called Y. I don't even think they would have anything to do with coordinate systems. That's just the way I want to define this particular record. And so this time we want to, let's see, how far should we stretch this one? Define sub, we define a subroutine. We just call this subroutine add, okay? I just called it add here. It's using pass by reference, and the parameter I will just call P here is of the type ABC. And what I want to do with this parameter is P.x gets P.x plus P.y. Okay, I'm just adding the two members and the sum gets stored into the first one. And define sub, that's my first subroutine. And then we have another subroutine here, okay? And we just say, add all, okay? So this one is going to take on an array of records. So we're going to pass by reference. A is the name of the parameter, and this is going to be an array of ABCs. In other words, it is an array, but it's an array of records. Within this one, we have a local variable I, which is going to be an integer, and we initialize I to 0, and we say while I is less than bar A bar, which is the number of elements in the array, do the following. And all we're going to do is to invoke ABC, we invoke add, and what we're going to do is to pass A bracket I by reference to parameter P. We add 1 to I, so we move on to the next element if there is one, and while, and define sub, and then we fix all the indentations. Okay, and now we're going to define, I forgot, one line. There we go. So now we define the last one, which is the main subroutine, define sub main. And inside the main subroutine, we have a local variable. I'll call this B. B is an array of 2 ABCs. So this time I make it clear the number of elements in the array. And we also want to do some initialization here. So I'll just go ahead and randomly initialize the values. So B bracket 0x has a value of 6. B bracket 0 dot y has a value of 7. B bracket 1 dot x has a value of 23. And then B bracket 1 dot y has a value of -5. Just some random values just to make sure everything has a value. And then we say invoke the subroutine at all. And then we pass the array called B, which is my local variable in main, to parameter A of the subroutine. And define sub, invoke main, fix the indentations here. And now we have the whole program. This is the program that we're going to trace and find out, okay, what is this program going to do? We have the program with all the line numbers, and now we can start the actual trace. All right, so as you would probably imagine, this one does get a little busy. We're gonna get a little bit more columns. So the way I'm gonna trace this one is going to turn the trace window itself into the horizontal arrangement, and by rearranging this up and down, we can see different parts of the source code. Okay, it's just this is a better way to display when we have lots of columns. All right, so we start with we don't need comments. There are we do have a while loop, so we need comments. Sorry, there we go. And we have the line number here. The precondition has nothing to say because there are no global variables. B is not a global. B is specifically a local variable of the type of an array of 2 ABCs. So now we start with line 26. Return line number is post, boring stuff. And now we need to specify the local variable. There's one local variable, which is B. But B as one single local variable is an array, but it is an array of ABCs. So each element is going to be of the record type ABC, which has 2 members, each member being an integer. So when you look at B, the first thing you have to say is to say, okay, it is an array, it has 2 elements. Okay, how do we know it has 2 elements? Because when I declare B, I specifically say it is an array of 2 records, ABC. But each record or each element in being a record of ABC has its members of XY. So we have XY here and then we have XY here. So if I want to emphasize what is B, how many columns is it consuming? 4. That's B. If I look at B bracket 0, which is the first element of the array, it is taking up 2 columns because by itself it is a record. And the same thing for B bracket 1, which is also consuming 2 columns. So in the spreadsheet, I can use this notation to clearly indicate that B is taking up 4 columns. B bracket 0 takes up 2 columns. B bracket 1 also takes up 2 columns. And then of the element, we can now have XY as individual columns. Are we doing okay so far with how we use up 4 columns for array B, even though B only has 2 elements?
4 columns, 3 rows. 4 columns, 3 rows.
4 columns, yep. But we use 3 rows to indicate all the levels of details. But we have all question marks because now we have 4 question marks because there are 4 different values involved. So when we start the whole thing, we have to say on line 20, line 20 is only going to initialize column D. So that's the only one that is changing from a question mark to 6. Line 21 deals with the next one. Line 22 goes to the next one.
You're in the wrong column.
Yeah.
Huh? What?
You're in the wrong column for your line numbers.
You're putting your
Oh,
line
okay.
in the red line.
Sorry. There we go. Thank you. On line 23, we are changing the last column to -5. So now we have all the values initialized. And here comes the call to add all. So on line 24, we are invoking add all. We're passing B, or we're using B to specify parameter A. So we'll deal with the easy stuff first, the return line number. When we get back, there's nothing else to do on line 24. Let's proceed to line 25. So that's the easy part. And then we have to specify a parameter, which is parameter A. It's passed by reference. Now this is the important part. This is AKA columns, okay? Because we are using B, which is an array of 2 ABCs, so when we use that to specify parameter A, we have to say this is also known as column D to column G. Are we okay with this concept? Okay. All right. And it has a local variable I2, so I is a local variable that starts with an unknown value. Now the important part here is A as a pass by reference parameter. No matter how big or how huge the array or record that you're passing to this thing by reference, it is only going to use up 1 column. So the alias is always going to be only 1 column.
Unless you're specifying children within B.
Unless you have multiple parameters. But each pass by reference parameter only consumes and uses up 1 single column. Okay? So that's kind of important because it links to some concepts that many of you will learn in cisp 310. So that's why this is kind of important because this is a concept that you will see again in another class. Yep.
Where did you get I from?
I is a local variable of at all. This is where it comes from. Okay. So now that we are done with main for the most part, for the time being, I'm going to switch to at all. And I'm just trying to figure out how to display that. Well, we can shrink it a little bit. Yeah, there we go. That works. There we go. There we go. Line 12 is fine because the other lines do not really indicate anything to do. So now that the columns are set up, we go to line 12, which initializes the local variable I to 0. And then on line 13, we have the beginning of a loop. Now, this is another question. What is bar A bar? Now, when you look at A, it is an alias of 4 columns. So bar A bar, is it 4? Nope, it's only 2. Now, how do I know not to interpret column D to column G as an array of 4 integers? Because that certainly is one way to look at it. Well, it is kind of spelled out here, right? It is an array of ABCs. So you have to count the columns based on how many columns each ABC is going to take up. But since one ABC is going to take up 2 columns, that means with 4 columns, it only has 2 elements. Are we doing okay so far with these concepts? Because it's a combination of concepts that we have learned, and it's the rationale that is important, because we need to know how many elements we're dealing with, but each element is one ABC. But in this case, since I is 0, 0 is less than 2 is true. We go to the next line, which is line 14. Line 14 is going to invoke the subroutine called add. So once again, we have to allocate return line number. This time it's going to go back to line 15. We have to pass the parameter by reference again. So this time we are passing something to parameter p, and we are passing a bracket I to parameter p. Now this is also something that's kind of interesting because a itself is passed by reference to me, and I'm using one element of the array that is passed by reference to me to pass by reference again to p. So if you're concerned about the mechanism itself, then you have to you have to take a step back and ask, what is the purpose of passing by reference? Passing by reference allows the subroutine to have access to something that does not belong to the subroutine. So in this case, P is passed by reference, but what is the type of parameter P? It's an ABC, right? So that means the objective of doing this is so that the add subroutine has the reference or a way to find a particular ABC record, be able to change the inside of that record. That's the rationale. So using that rationale, what should I use here in column L to specify it is also known as, what should we do here? D and E, exactly. So it's going to be columns D to E, which are the columns corresponding to the first element of the array. Is that okay? So in other words, we are not really just looking at the mechanism, which is the how of doing things. We are also looking at what we are doing with this and also why we are doing it, because all of those questions are related. Okay, so now that we have this parameter passed, we're going to move on to that subroutine, which is over here. And I don't know how to scroll this, but instead of doing that, I can always just shrink this window so that we can move the relevant part to be displayed like so, and then superimpose or put the other one on top. So there we go. All right, so we are going on to line 7, which is the only line that actually does something useful in the subroutine add. And in here, it says we want to first access the member X of P and add the member Y of P together. Okay, so let's check out what is P. P is also known as columns D to E. but because we need to look at column D and E as a record type of ABC, so that means we have to look at this one, column D as the X member, we have to look at column Y as the, column E as the Y member. So we're adding these two, which is 13, and on line 7, we want to store that back into P.X. Once again, P is also known as column D to column E, and because of the type of the parameter, we have to look at those two columns as a record type of ABC, and we want to store into the first member, the member X, so that means column D is the one that is changed to the sum of the two, which is 13. Do we have any questions about row 17 of the trace? Because that really is the bottom line of this example, is the combination of all of these concepts. No questions? It's all good? All right. So the next one is just, we're getting out of the subroutine on line 8. So line 8 doesn't really do anything exciting. All it does is to make a note that we continue execution on line 15 and deallocate the 2 columns for this invocation. So that part is not exactly very exciting. Now we're back on line 15. Line 15 is just saying add 1 to I. Okay, find the column with a label of I that is the rightmost one. Turns out to be column J, so column J is the one that is up, we're counting up to 1. Then we go back to the beginning of the loop, which is on line 13. I is now 1. 1 is less than 2 is true. So we go back into the body of the loop, we go to line 14 again, and this time, we are going to do about the same thing as last time, so I'm going to copy and paste some of this. But P is now different because we are passing A bracket 1 to parameter P. A bracket 1 refers to the second element of the array, and the second element of the array refers to column F and column G. So, whoops, there we go. Okay, so that's why this is changed. It is no longer column D to E, it is now column F to J, because we are referring to the second element of the array.
F to G.
Sorry?
F to G.
F?
to J.
Oh, F to G, sorry. Yeah. I read one thing and will say something else. I'll be an excellent politician. So Trump can count himself lucky this year. And I have my platform too. My platform is all elementary schools should start teaching binary numbers instead of base 10 numbers. I think all the parents will support me.
I'll support it.
Especially, huh?
I'll support it.
Yeah, I will support myself.
They'll probably just think, oh, that sounds smart. And then
Huh?
they'll probably just think, oh, that sounds smart, and then they'll just go through with it.
Well, when I tell people the multiplication table of binary numbers is only 2 by 2, that's when I will win the election. It's like, okay, hands down, there's no competition anymore. Because I just made the multiplication table from 10 by 10 to 2 by 2.
You get up to 1,023 on 2 hands if you're counting by that.
Oh, you have spare fingers now.
I know.
We don't need all the fingers anymore.
Unfortunately, when you get to numbers like 4 and 5, you start offending people.
4 would definitely be offensive, yes. Yep.
How did you get 1 again in line 19 of the trace for column J?
On line 19 here, this is because we're adding 1 to I, and column J is local variable I of add all.
Okay.
Okay. And this is the beauty of a trace, is I can digress and talk about other stuff, and I can still answer questions about any row of the trace, because everything this program has ever done so far is recorded. Okay? And this is the only class where you can actually visualize how everything changes over time, because when you move on to the next class, it doesn't care, I don't even care what programming language you're going to learn. It can be Python, it can be PHP, it can be JavaScript, it can be Java, it can be C, it can be C++. You won't be able to visualize anymore because there are no tools to help you visualize. as you execute the program. Which is kind of a bummer on one hand. On the other hand, you don't have to tediously do this anymore. But it does make debugging a program kind of problematic when you cannot see everything that has happened.
You just add print statements after every function.
You just have to what?
Add print statements after every function.
No, you use the debugger. Some of you will see me again and you will know what is GDB at that time. Alright, so after line 14, what do? Line 14 is the invocation. So after line 14, we get to the beginning of the subroutine that we're invoking, which is ABC, which is add. It only has one line that is useful, which is line 7. So we go back to line 7 here. Line 7 says, I want to add the two members, X and Y, together. The two members of P is referring to column F to column G. And because of the type of P, I am forced to look at column F to G as a record of ABC. That means column F has to be interpreted as the member X, column G has to be interpreted as member Y of the same record. So we look at column F and G, 23 and -5, you add those two together, we get 18. We want to store the sum back into P.X. Once again, P is referring to column F to G, but because of the type of P, we are forced to look at those two columns as a single record of ABC. And out of those two columns, column F is the one that is member X. So this is the one that is updated to a value of 18. Then we're done with line 8. We're done with line 7. We move on to line 8, and nothing really exciting happens. We just have to remember where to go back to, which is line 15. Deallocate the two columns for this invocation. And let's see, strike through. And now we continue execution on line 15. Line 15 is adding 1 to I. So we first have to locate the column that has a label of I, which is column J. So column J has a label of I. It currently has a value of 1. By adding 1 more to it, it becomes 2. And after that, we have to go back to line 13, which is the beginning of the loop. So on line 13, we re-evaluate the condition. I, which is now 2, is less than bar A bar, which is also 2. This is now false, because 2 is not less than 2. So we get out of the loop, and we get to line 17. On line 17, there's not much exciting going on, because we just have to say, okay, we are at the end of an invocation of a subroutine. Where am I going? Look up the return line number. We are supposed to go back to line 25. Okay. And then we have no use of the 3 columns for this invocation. So we deallocate columns H, I, and J right here. And now we continue execution on line 25. Line 25 is the end of the main subroutine. Once again, nothing really exciting is happening. We look up the return line number, which says post. So we say, okay, next we go to post, and then we deallocate all the columns corresponding to this invocation. So that will include all 5 columns, not just column C and D, because B as a local variable is taking up 4 columns. So we deallocate all of this. If you want to be very specific about the fact that we are deallocating everything, at least in the case of a spreadsheet, it's easy to do this. So I can do a copy. Oh, it doesn't let me do that. Well, it displays some message. I have no idea what it is. So you can see, no, it doesn't let me do that. Okay, fine. So we can only do this part and put it here, and then do the strike through like that. Now we are on to post, which means everything is done. Yep.
Like zoom out.
Zoom out. Okay.
I'm off by 1 line for some reason. But if you look at the numbers on the left.
Numbers on the left.
Like the spreadsheet row count.
Off by 1. I don't. Where is it off by 1?
I don't know, but so my post is
Okay. So let's double check. Line 17, okay, 13, 17, and 25. Let's see if we missed anything. Okay. 17 goes back to 25. 25 is the end. It goes back to post. So that part is not a problem. Can you see how it is different from yours?
No.
Okay, where does it start to be different from yours?
I don't see any difference right now.
Oh, okay.
Just forget the space one more.
Okay, 7, 8, 15, 13, 14, you know, this is the last loop. And then when 13 gets a false condition, it exits the loop to the end of the subroutine that goes back to the end of main, and from main we continue on to, from the invocation of main we continue to post.
You go back up to,
Do you hear rows and question
Okay.
marks? Huh?
I just don't have a pre-line.
Oh, okay. No precondition, okay. There we go. Yep.
Can you upload this example on Moodle?
Why? You have it already. You know, this is on display here. When you look at it, it's different from when you, okay, so what you should do, okay, or what, I shouldn't say what you should do because I don't want to tell people what to do, even as a professor, okay, because I looked up what is Taoism and I think, you know, that's good. So I'm not going to tell you guys what to do. So if I were you, I would go through the algorithm. In other words, I would go back to the algorithm itself, okay, which is this part here. So I would go back to this one. Unless you have a photographic memory, you probably cannot remember exactly how the algorithm was traced, and I would do it myself. I would just go through this whole process on the spreadsheet so they don't have to spend a lot of time writing. And then I would go proceed with the video and check whether you end up with the same result as this one out. Which means I'm not going to save the file and put it onto Moodle, but you can look at this code and trace it yourself. But I think that would be a useful experience as far as getting ready for the test is concerned.
So I was saying it would be more easy if I can just download the file and like look at the code and start it.
You mean the trace itself? Okay. This is where things can get, if I were you, if I look at the solution and say, okay, so this is the solution, I can follow this line by line, row by row, and everything, it's not the same thing as doing the trace myself by hand first, and then checking to make sure that my solution, that my answer turned out to be the same thing as what I presented in the class. So the process of actually doing it is more productive, at least for me, compared to just reading the answer itself line by line or row by row. Okay, so for that reason, I'm not going to upload the spreadsheet. Okay, but I do want to make it easier for you guys to see the actual end result, and that's why I zoom out so that you can see the entire thing. Yep. Question? Nope. Okay, so for those of you who want to be able to print this out and say, okay, since this particular spreadsheet is going to span across multiple screens in a screenshot, how do I combine this into one single sheet of paper if I want to bring that to the exam? Okay, so this is how you do it. Okay, so I have this part here looking at the first part. I scroll down here, which is the second part. So you take two separate screenshots, and then you just do the GIMP thing or do whatever you need to kind of splice the two images or portions of that together. Then you have the whole thing.
It's more time consuming than just typing it out in the first place.
Exactly. So the whole point is, the best way to prepare for the test is not to read my answer, but to go through the process, work it out, and then compare your answer to what I have here. The comparing part is not going to be very time consuming. You just freeze the frame in YouTube, and then you open your spreadsheet on the other side. You just go by row and go like, okay, the same, different. Okay, if it's different, why are they different? Okay, it's not just just a matter of, oh, it's different. Let me memorize what tag had in class. That won't be helpful, guaranteed. But not a money back guarantee. I just guarantee it. Okay, so what you need to do if they're different, you need to ask why are they different. Okay, why did I choose to do it this way, and why did tag did it differently in class? Because by understanding why it is different, if you encounter the same kind of situation in the final exam, you know exactly how to proceed. On the other hand, if you just memorize my solution, if there's any difference in this exam question, then you cannot just reapply what you have memorized, because what you have memorized is very specific to a particular combination of the concepts. If I combine the concepts in a slightly different way, the memorization is not going to be helpful. Yep.
Can I squash an array of records down into like A0.x, do all 4 columns that way, but not take up 3 rows?
Oh, okay. You mean over here? How to denote these?
Yeah.
As long as I can see that you understand B is taking up 4 columns.
B0.x, B0.
Yeah, sure. Yeah. So what he meant? Yep. Go ahead.
Oh, sorry. I was just gonna ask if on the final exam, are you gonna have us do the student ID number again?
Oh yeah.
Okay.
So you guys will have. So I will basically say, okay, initialize the columns based on your student ID. Kind of like the stuff here. So you just pick out your first student ID or the first 4 digits and put it here.
Okay.
Oh, but just the first one.
Oh, okay.
Yeah, all 7 was kind of killer last time.
Sorry?
All 7 was kind of killer last time.
What is killer?
Oh, like
Using all 7 numbers.
Yeah.
Oh, the 7 numbers? Well, there was one that seemed to be going to be long, but because I stepped by 3 instead of 1, so there were only 3 calls that are recursive instead of 7. So some people look at it and go like, oh, this is going to be long. Nope. 3, 1, 3, and then 7, or 0, 3, and then 6. You're done. Okay. Any other questions? Bring extra pieces of paper. And if you do need the extra paper, okay, this is the tip. If you bring extra pieces of paper, you might as well just line them first, or just get graph paper. So they are all lined to begin with, they're squares and stuff like that, easy to follow. The second thing you want to do before the test is, if you think you might need about 5 sheets of paper extra, write your name before the test on those 5 sheets of paper. So this way, if you do need those 5 sheets of paper, your name is already on it. You won't be using time to write your name on those extra 5 sheets of paper. So get all this stuff done so you're well prepared before the test. By the time the test starts, then you can just focus on the questions instead of all the logistic stuff. Okay, any other questions? I think we got 2 minutes left. What is the time? We just looked it up earlier. Yep.
Are you gonna upload this today?
Yes, I will upload it today. If it is not uploaded, or for whatever reason you cannot access, send me an email. Sometimes I would upload, but I forget to publish it, so it will stay in a private listing, so you guys cannot see it. So if, at the end of the day, if you cannot find it or see it, just let me know. Okay. All right. So I think you guys have a long weekend to study.
Yes.
Okay. I'm not going to say good luck, because luck has nothing to do with an exam. So I'll just say study hard and study right.